This lesson reviews the procedures for a paired t-test. In the end, it's much like a t-test, except that the data originally is paired, and then we're comparing the before and after. In this case, it's about truck drivers, seeing if changing their work week changes their mileage. So it's the same drivers before and after the change in their schedule. I've already put in the data in my L1 and L2. And then what we have to do is simply calculate the differences per pair. And I can do that easily by going up to L3 and choosing it, and then going second L1 minus L2, and it puts the differences straight in. So this first driver, his number of miles went down by 116. So for the conditions here, instead of doing two histograms to show nearly normal, you simply do a histogram of the differences. So I'm going to quit out, go up to stat plot, make sure it's on, that it's a histogram, and I'm going to make sure it's at L3. I'm going to do zoom 9. There we go. So it's nearly normal. It's unimodal and symmetric for the most part. Now I'm going to simply do a t-test, and it's data, not stats, because I have it in there. My null hypothesis is that there is no difference. And then my alternative hypothesis is that there is a difference. I don't know if it's more or less miles, so I'm leaving it at a two-tailed. And then I'm making sure that my list is at L3 and not L1 or L2. I'm going to calculate, and it comes up with a p-value of 0.017, which is a very small number. So my conclusion can be, with a p-value this small, we can reject the null hypothesis. We conclude that the change in work week did lead to a change in driving mileage. And you can see here the mechanics that I would have to show for full credit on the AP exam.